Hello students, this is the 10th video that I've prepared to explain how to use this Casio GDC using IV Math SL questions. So let us continue. Now problem number 26 uh, is given note radians are used throughout this question. Let f of x equal to sine of 1 plus sine x. Sketch the graph of y equal to f of x for x between 0 and 6. So let me use graph. So sine of 1 plus sine x, close the bracket, for x between 0 and 6. So shift view window 0 and 6. Okay. Now y maximum minimum, let me leave it as it is. Okay. So this is what you get. Write down the x coordinates of all minimum and maximum points of f in this domain and give your answers correct to 4 significant figures. Okay. Before that, let me change the scale, shift view window. I'll make it as, let's say, -1 to +1. Yeah. So now let us G-solve. First look at maximum points. So one maximum, they're asking you to find the x coordinates of the maximum minimum point. So the first answer is 0.6075. That is answer number 1. And second answer is 2.534. That's it. So now next for minima. One answer is 1.571, 4 significant figures. And next answer is 4.712. That's all. Okay, so next part. Let S be the region in the first quadrant completely enclosed by the graph of F and both, this is in bold font, both coordinate axes. So we're talking about this part till here. Okay, till here, this part. So you have to shade it. Write down the integral which represents the area of S. So to write down the integral, you need to find out the vertical lines which form the boundary, which form the boundaries of this area, this shaded region. Okay, this is x equal to 0, and this one, let me find G-solve root. So 4.712. Okay, so the integral should be 0 to 4.71239 sine of 1 plus sine x dx. So that will be the integral. And evaluate the area of S to 4 significant figures. So let me use 4.712. So let me use sine of 1 plus sine x, close the bracket. So 0 to 4.712. So 4.712. So is the answer 3. They're given 4 significant figures. So the answer is 3.517, students. Okay. So that's it. The last part, give reasons why f of x is greater than or equal to 0 for all values of x. Basically, sin x lies between -1 and +1, students. Okay. The maximum value is 1 and minimum value is -1. So 1 plus sin x, the minimum value will be 0 and the maximum value will be 2. Okay. I hope you're able to follow me. So let me try to explain. So let me type it here. Okay. So you know that sin x lies between -1 and +1. So which means 1 plus sin x. So add 1 throughout, you get 0, 1 plus sine x. So 1 plus sine x lies between 0 and 2 by adding 1 throughout. So basically you have this, sorry, this is f of x. Yeah. So f of x lies between, not f of x, I'm sorry, this is 1 plus sine x. Okay. Now we know that if this expression 1 plus sine x lies between 0 and 2, which means we're talking about the first and second quadrant. And we know that sine is always positive in the first and second quadrant, isn't it? First and second quadrant means I'm talking about 0 to pi, which is 0 to 3.14. So if this 1 plus sine x takes any values between 0 and 0 to 3.14, the sign of this value will be either positive or equal to 0. But since here we just now saw that 1 plus sin x, it takes all values between 0 and 2. So definitely this f of x has to be greater than or equal to 0. So I hope you understood this. So let me close this. Okay, fine. Sorry. So let us look at the 27th problem now. Okay. Radians are used throughout this question. Draw the graph of y equal to pi plus x cos x for x between 0 and 5. Okay. So, graph pi, so shift pi plus x cos x. So x cos x between 0 and 5. So shift window 0 and 5. So I'll make it as, let's say, -4 to +4. Okay, you get this figure. Now without the use of calculator, show that pi is a solution of the equation. So what you need to do is you replace x with pi. So pi plus pi cos pi. So let us see the answer scheme. I think it is here. Yeah. So pi plus pi cos pi. You know that cos pi is -1. So you'll get pi minus 5, which is 0. So this is how you prove that pi is a solution without using a calculator. So let us look at the next part. Find another solution between 0 and 5 and giving an answer to 6 significant figures. So let me rearrange it. Gsolve root. So one is 3.14, which is pi. The other one is 3.69672. So the answer is 3.69672. Let us check. Yeah, that is correct. And next one, let R be the region enclosed with the graph and the axis for x between 0 to pi. Okay, so we're talking about this area. We're talking about this area. Shade the area. So this is how it looks like here. This part is shaded. Fine. Evaluate the integral in part D to an accuracy of 6 significant figures. Again, you can use a calculator. So it is basically 0 to pi, pi plus x cos x dx. So here 0 to pi plus x cos x dx, which you can use the calculator. You can find the answer using the calculator. So here, exit. Let me delete this. Go here, math, integral. So you can do it here. So let me type it. So pi plus x cos x. Close the bracket. 0 to pi. So 0 to 3.14, right? 0 to pi. Shift pi. So the answer is 7.86960. So 7.86960. That's fine. Good. So let us look at the last two problems of this video. The following diagram shows triangle ABC. AB is length of AB is 7 centimeter, BC is 9 centimeter, and the angle is 120 degrees. Find AC. You can use the cosine rule, isn't it, students? But again, the reason why I included this problem in this worksheet is to make you understand that it is given in degrees. So when you use the calculator, okay, so exit. So let me go to run mode. Oh, sorry, this is the run mode. So let me delete everything. Okay, so here the expression is AC equal to square root of 7 square plus 9 square minus 2 times 7 times 9 into cos 120. So now here, if you type shift square root of, sorry, delete, okay, shift square root of 7 square, which is 49, plus 9 square, which is 81, minus 2 times 7 times 9 into cos 120. Now, if you type this answer is incorrect. And the reason is the input mode, the angle is in radian. So you have to change it in degrees. So shift menu to make it to radian degrees. Yeah. Now if you type 49 plus 81 minus 2 times 7 times 9 into cos 120. So you can see that the correct answer is 13.9. Three significant figures. Okay. Let us look at the next problem. The following diagram shows the triangle ABC. The angle at C is obtuse. AC is 5 centimeter, BC is 13.6, and the area is 20 square centimeter. Find ACB. So we know that the area of a triangle is half into product of two sides multiplied by sine of the angle between them. So I'm going to take this angle, the obtuse angle ACB, as x. So you get sine x equal to 40 by 68 and x equal to sine inverse of 40 by 68. Now again, students, here you have to change it into radians. Okay, it's not mentioned anywhere here, so you have to take it as radians. So shift menu, make it as radians. Okay, so let me find sine inverse of 40 by 68. So 40 divided by 68. Now you're getting 0.629 as the answer. Now 0.629 is nothing but an acute angle, isn't it? Because acute angle is any angle between 0 and 90, greater than 0 and less than 90. So which is nothing but 0 to pi by 2, which is nothing but 0 to 1.57. Okay, any angle in radian, if it is expressed in radian, between 0 and 1.57 is in first quadrant. So for it to be in second quadrant, it should be between 1.57 and 3.14. That is pi by 2 to pi, 90 degrees to 180 degrees. So what you need to do is, to get that answer, you need to subtract this answer from pi. So that will be the solution. So here, shift pi minus. So the answer is 2.51. Okay, so the answer for this particular problem is 2.51. Okay, I hope you got it. So that's it, students, in this video. Thank you. Thanks for watching it.